Hello everyone, welcome to our PBL Level 1 Physics project. Today we're going to talk about how to measure speed of an object. Why is it important? Why do we measure the speed of an object, and when am I going to use that? And actually we use this every day. We don't even know, but we use that every day. For example, when we are driving, when we are going on a traffic, we have our GPS systems and it tells you how long it's going to take, right? And have you ever wondered how they do it? It's very simple. All they do is measure the distance in between the your final and initial destinations, and then it's going to measure the distance in between and it's going to measure the time. But how does he know that how long it will take? Yes, you are going to know the distance from the map, but how do you know how long it will take? Well, they're really well defined, and then they know all of the speed limits in everywhere. So they just divide the distances by the speed limits and then they just add those numbers. Well, it's not that simple, but that's basically how it works. And they also, if there's a light, then they're adding plus minus some minutes, and then it gives you really good accurate number. I was always confused, I was always testing those GPS systems, but most of the time they are really good accurate systems. And today we're going to figure out how to measure our own car's speed. All right, let's introduce our materials. First, we're going to need a constant speed card. And it's important that this car is not just a regular car. This is going with a constant speed, and it's important. If it's not accelerated, or if it's accelerated, we are not going to be able to measure the speed of it, or we need to use a different method, but it's a constant speed car. All right. And we're going to need a stopwatch to measure the time. And I'm going to use sticky notes to mark the places. And lastly, we're going to need our meter stick. All right, before we start to do our experiment, we need to learn how to use a stopwatch, because we're going to take data in a really short time, so it's not easy to stop and restart it again. So we're going to use the event tool of the stopwatch. So if you just take a data, if you just measure a time for one time, for example, you just start and stop, and it measures the time, and then you stop. But that's it. You cannot take the second data as the time goes on, and you can reset it over here. But if you want to take multiple time data when the time is going, what you do is you are starting. It's important that you start first, and then you're going to hit this event button. So if you hit event, it is going to stop the time over there. It's going to, you're not going to see that. The time is still going on, and then if you hit event again, it is going to record that time again, but it's going to be in the back, so you can't really see what it is. So hit it again. And the last data, when you're done with your last data, you stop it. And now you have 4 datas. And if you want to know what the time was when you hit that event button, so that the same button again, you can see recall over here. When you hit it, it is going to tell you what was the first time that you hit the time button. So it was 9.87 seconds. And if you want to know what was the second one, you hit it again, and it's going to tell you what was the second data for the time. And if you hit it again, that's going to tell you the third one. So you can take as many as you want, and you start with the start and you end with the start button again. And any data in between, you're going to hit the event button, and then that's going to record those datas. And if you want to clear this data memory, you need to hit that reset, but hitting once is not going to be enough for that. You have to hit it, and then you got to hold it so that it's going to remove the stored data in its memory. All right, the other important thing is about our constant car, and you're going to have an on and off button over here when you turn it on. it's going to start. But a little bit problem with the cart, it's not going straight. So you need to make sure that you're going to have on the side, on the road, that is going to be a little bit higher than the level of the tire. So it's not going to get out of the way. It's going to go straight, so you're going to be able to collect the correct data. And in my experiment, I'm going to use the ruler itself, like meter stick itself, but it doesn't have to be meter stick. It can be anything that is going to block the car to go on the sides. So it's going to go in a straight line. All right. And the other important thing about the cart, we're going to start this, but we cannot start the cart and then start to collecting data. So we're going to turn it on, and then we're going to hold it in the air. And then when we are ready, we're going to release it. And again, we are not going to start to collect the data. Once it starts to move, you're going to start a little bit ahead so that you're going to get ready to get your first data. You're going to start collecting data. So turn it on, hold it in the air. When you're ready, leave it on the table, and then when it passes through the point, the first point that you set, you start, and then you're going to collect your data afterwards. So it's important that you are starting on the air, you're not starting on the table. All right, and sticky notes. The purpose of the sticky note is marking each point. So what we're going to do is, on the road, we're going to put those sticky notes, and the first one is going to be the start one. So we're going to put that sticky note wherever we want to start with, and then we're going to write start on it, and then we're going to put those sticky notes every 50 centimeters, and then we're going to mark the length on the sticky notes, and then we're going to know where we're going to collect the data. So, and the experiment is very simple. All you need to do is you're going to start your cart, and every time that your cart passes that sticky note or your 0.5 meters, then you're going to press the collecting data. So each time that you pass, you're going to start, you're going to hit the event button, and that is going to collect the datas, the times at those points. And then at the end, we're going to know what is the time to go to travel for half meter, what is the time to travel 1 meter, and it is going to go on like this. All right, now we're going to mark our points. So we're going to start with the sticky note, and then I'm going to start the cart at this point, but I'm not going to start to collecting data at this point. I'm going to start collecting data at 50 centimeters. And make sure that you are going to put that sticky note, the right side, the end of the sticky note is going to be at the 50 centimeters mark. And I am going to start from this point, and this is going to be my start point. And I'm going to collect data every 50 centimeters. So I'm going to go on. This is my first point, 50 centimeters. So that's going to be 1 meter. And this is basically 0.5 meters. And then my next data point is going to be another 50 centimeters. And I'm going to put another sticky note over here. And this is going to be 1 meter. And we're going to go on like this. And this is going to be 1.5. 50 centimeters more. This is 2 meters. And our last data point, which is going to be the end, is going to be 2.5 meters. All right, now we are ready to do the experiment. Let's turn on the cart and make sure that we're going to hold it on the air before we start. And then we are ready, we're going to hit the start button when it passes through the start point. All right, so 3, set, go. All right, now we have collected the data, and I'm going to need this data. And over here, I have distances, and these are my distances that I measured at time. And I did the same thing 3 times so that I'm going to have a better calculations, because since we are measuring the time in 0.5 meters and it takes around like 1 second, and it's not really easy to get the correct data for each 50 centimeters. So it's better to have 3 trials and then get the average of the time. All right, so that's what we have over here, but how is this gonna help? What is this gonna do? And we are trying to find the speed of the car. So how can we find the speed of a car? Speed is measured distance over time. So now we have our distances over here, and we know the times for that. So if we have distance time graph, then the slope is going to give me my velocity. So, and that's what I'm going to do, and I'm going to enter my data to the computer, and then after this I am going to find the slope, and that's going to be speed of my car. All right, now we're going to enter our data. My first trial was 1:14 and 2:13, 3:20, 4:19, and 5:20, 27. And my second trial was 1:15, 2:19. As you can see, these are pretty close datas, but they are off a little bit. So we're going to get the average to be able to get the better data. 5:36. And my third trial, 1:11, 2:22, 3:21, 4:29, 5:35. As you can see, these are pretty good and close datas, but they're a little bit off. So what we're going to do is we're going to find the average. And how do you find the average? This is an Excel file. So you can simply you can press enter, open the parentheses, click on this, add, click on the next data, add, click on the next one, close, and I have 3 data, so divide it by 3 and hit enter. So that is my average for all of those 3 datas. And if you go to the corner of the cell, and then if you bring it down by holding it, it is going to give you the averages of all of those data. And if you don't like those decimals, you can go to the left, top, and over here decrease the decimals. So you can decrease your decimals. And we're going to need like hundreds. So these are our final data. And now these are our distances and these are our times. So what we're going to do is we're going to have the graph of distance to time. And to be able to do this, we're going to go to our Pascal capstone program. All right, now we're going to have the table, and we're going to have select measurement, and we're going to create our own user enter data. And this is going to be distance first, and hit enter. The unit is meters, and our data for this is going to be on our Excel file. So collect those, select them, copy them, and paste them. And go to the next one, create new user enter data. That is your time. Hit enter, is measured in seconds, and then go back to your times, and then make sure that you are selecting your average times, copy them, and paste them. All right, now we have our data, and what we're going to do, we're going to draw the graph of this. And to be able to do this, we're going to have a new page, and that is add a page. And you're going to double click on the graph, and on the select measurement on the left, we're going to have distance. As you can see, this is user entered data, and then that is the index, but we're going to change it to time. So as you can see, that's a pretty nice data, and we're going to have the slope of this, and the slope of this guy is linear, and that is going to give me my speed. So my slope is 0.47 or 48. That is my slope, and basically this is distance over time, and distance over time is equal to velocity. So basically it is given a constant speed, and its speed is 0.48 meters per second. And this is the end of our experiment. All right, we have measured our speed of the carts, our lovely cart. And where do we use this? Or who is using this? And cops are using this system a lot because they have radar systems, right? They have I don't know if you've ever seen it, but they have like a camera kind of thing, and then they are basically holding it to you, and then they chasing you, and then tell you that's your speed. And if you are above the speed limit, then you got your ticket. And basically that's where we use those. Radar systems are using that very simple system. And again, the way that they work is a little bit different. Instead of measuring the times, they are basically sending sound signals, and it releases from the radar and it hits to your car and comes back, and it measures that distance. Just like we did, we are measuring the distance. And it is locating those points, and when he measures, it is sending, it knows the frequency of the sound wave. So every, let's say, 1 second, it is sending a sound, and it is collecting all of the reflected data, and then it can figure out what the distance is, and then he can figure out what the speed of your car is. And then if you're above the speed limit, then you get your speeding ticket. So it's very important that we always drive safely and we do not go above the speed limit. And thank you for watching, and see you next time.